Hello everyone, it's indeed inspiring to see you back again, and we are discussing Introduction to Apache Flink. Let me help you to understand what exactly is Apache Flink. It is a framework and distributed processing engine for stateful computations over unbounded and bounded data streams. So Apache Flink is similar to Apache Spark. If you have got any idea of Apache Hadoop or Apache Spark, you understand that they also are distributed processing engine. Very similar way, Apache Flink is also a distributed processing engine. It can work on batch processing or it can also work on the streaming data. So that is what is the meaning of bounded and unbounded data streams. Flink has been designed to run in all common cluster environments, perform computations at in-memory speed at any scale. Therefore, Flink has been loved by everyone after Apache Spark, that is what I can say. Let us move ahead and try to understand more on the architectural side of Apache Flink. Apache Flink works on Kappa architecture. I'll be explaining you on that as well. So Kappa architecture, it has got a single processor stream which treats all input as stream and the streaming engine processes the data in real time. So that is what is required by the companies, that the data should get processed in real time. For example, as soon as you get some message on a critical node, so immediately that data should get processed and the desired action should get triggered. So that is what Flink tries to achieve. So batch data in Kappa architecture is a special case of streaming. So that means you can analyze and process the streaming data at the same time. Batch data is also one of the special case in Flink. Therefore, batch processing is also possible. In this particular diagram, you can see that we have incoming data and it goes to the real-time server, which is streaming engine, and then we have a backend serving layer, and then you perform your desired query. Let us understand the whole of the ecosystem. So here you can see that we have an engine. This particular engine, if you see, that is called as Flink's runtime. So Flink has got its own engine which basically manages up the whole of the session which Flink runs. Then it has got abstractions. Abstraction means that it has got dataset API and it has got data stream API. Dataset API, it is responsible for batch processing. Data stream API is responsible for streaming data processing. Then we have other libraries also. Table is there, Jelly is there, and Flink ML is there, which works on the data sets when we process batch processing. Then we have Zeppelin. This also is a tool for visualizing and interacting with the data. Then if I want to deploy Flink, I can deploy Flink on a local JVM. I can create a cluster with the help of Yarn, or I can make it stand alone, or basically I can run with some other environments as well, which we will later on see. This is a repetition which is shown in the presentation. Now we have storage layers. So storage layers, if you see that we have file systems like local file system, SDFS or Amazon S3. We can work with databases like MongoDB and HBase. Then we have streams like Kafka streams, Flume streams, or RabbitMQ stream. So this is what is the whole of the Flink ecosystem. Let us move ahead and try to understand more about it. So the key idea in Kappa architecture is to handle both batch and real-time data through a single stream processing engine. So there will be a single stream processing engine. Here you can see that how a job will get processed. So the program will be submitted by a component called as client. Client will basically compile and optimize the program, and then it will submit it to the job manager. So the component job manager is like a master component and task managers are like slave components. Here you can very easily make an analogy between Hadoop's name node and data nodes, or resource manager and the executors. We have their node managers. So here the job manager's responsibility is for scheduling, and we have resource management responsibility given to the job manager. When a particular program comes to job manager, it deploys that particular task, and then a task manager is responsible for executing the deployed task. Task manager's responsibility is to execute the task and exchange the data, because it also works in distributed environment, so the data will lie in multiple machines. So this is how basically task manager executes and it sends the data, it sends the status of the job back to the job manager, so that job manager is aware what is the current status of that particular job. Now let us understand what exactly is a program. So it is a piece of code which we can run in a Flink cluster. It can be written in Python, Java or Scala. Client is responsible for taking the code, constructing the job. So client is the a component of Flink itself, then passing it to the job manager. It will also retrieve the results which we can see through some UI. It may be a command line interface or some UI interface, web UI could be there. Then we have next component as job manager, which is responsible for receiving the job from the client, and it receives the data flow graph. It is responsible for creating the whole of the execution graph, and it assigns the whole job to the task managers, and then it supervises the execution. It helps in scheduling and resource allocation to the task managers. Then task manager is actually responsible for doing the ground level task which is assigned by the job tracker, and then all the task trackers, they will run the assigned task, and they will report back to the job manager what is the status of that particular task. They will all have a separate slot for executing the task, and therefore we achieve parallelism here. Let us now focus on some of the features. I'll just help you out by reading out some of the features here. So it has got a streaming processor which can run both batch processing and stream programs. This is what we have discussed. It can process data at lightning fast speed. You can see that after Hadoop, Spark actually came, which can run 10 to 100 times faster than Hadoop. Then Apache Flink came into existence, which can again run faster than Apache Spark, because in Apache Spark it is mini batch processing which happens, but in this case it is really like a water pipeline which is continuously sending the data, or we can say streaming data analysis is happening. We have APIs available in Java, Scala and Python. It also provides APIs for common operations, which basically helps the developers to work for the programs in quick and easy manner. It processes the data with very low latency in nanoseconds and gives high throughput. It is fault tolerant like we have other systems as well. If a node or application or hardware fails, it doesn't really affect the whole of the cluster. So that is what is robustness it has got. It can easily integrate with Apache Hadoop, Apache MapReduce, Apache Spark, HBase and other big data tools. That really makes it very generic, and with whatever ecosystem, whatever architecture you are working, you can easily integrate Flink with it. It has got in-memory management, and it can be customized for better computation. It is highly scalable with a capacity of 1,000 nodes in a single cluster. Windowing is very much flexible in Apache Flink. It also provides graph processing, machine learning, complex event processing libraries. So these were few features of Apache Flink. I hope you enjoyed this video. Please do like, subscribe and share, and whatever queries you have, you can ask us in the comment box below. Thank you very much for watching.